Hello students, this is Dr. Faizan Mirza. I'm discussing with you how the motile organisms can be counted. You cannot use a quadrant for that because you cannot use an abundance cover scale for that because the organism is actually moving. In that case, you have to use mark, release and recapture technique. The technique is having various steps that you have to follow, and this technique was highlighted by Lincoln. So we end up calculating the Lincoln's index. The Lincoln's index is having the formula of n capital N, which is the population estimate. We'll multiply two counts with it, n1 and n2. N1 is the number of individuals which are marked and released, and n2 is the number of individuals recaptured. We'll divide it by the value m2. M2 is the number of organisms that were recaptured which were marked. How do we do that? We, for example, are calculating the number of organisms of this plant hopper. The brown plant hoppers. These are a serious concern for rice fields. They damage the crop, and they are insect pests. They are insect pest of rice. So how do we go about it? We use a mark, release and recapture technique. Now, what do we do that? We go into the defined area on day one, and when we go there, we start to just use a sweeping net. By using a sweeping net, we just catch these brown plant hoppers, and we try to catch a very large number. For example, we ended up catching 247 of these on day one. All of these that we capture on day one, we'll mark them with a non-toxic, waterproof, and a waterproof dye with a very small spot, so their camouflage is not affected. They don't end up getting cancer or irritation from that dye, and the dye should be waterproof, so it should not get washed off. So we release all of these 247 after marking them. Now we allow them to go and mix with their cousins, with their like ones in the field. The next day we'll come again, and the next day in the same defined area we'll come and we'll start to capture a very large number of the same plant hoppers using the sweeping nets in a very large quantity again. So on day two, if I was able to capture some 259 of these, so I get 259 plant hoppers on day two. So my day one count is 247, my day two count is 259. I allowed one day so that they could mingle with their population, so that they could mix. I will not allow more than one day. The time should be long enough for them to get mixed with the population, but not long enough for the migration in and out to occur or predation, because they can affect our total estimate. And the time should not be even way too short, so that they don't get a chance to mix with their actual population. So on day two, if my count was 259, and on my day one my count was 247, on day two among 259 I'll start to see which of the plant hoppers have the spot that I marked them with yesterday. So let's suppose out of those 259, I had 16 of these that had the mark which I had given them on the previous day. So this actually tells me that of these 257, 16 plant hoppers are the same that I met yesterday, and I'm meeting them today as well. But there are so many others which I did not meet again today because the total count is too high. Among all these 259, majority of these are the ones that I have come across for the first time today. So what I'll do, I'll just use the formula n1 multiplied by n2 divided by m2. So I'll multiply the two counts, the day one count, and multiply by the day two count. I'll divide these by the number of organisms that were found to be having the mark on the second day. So that's 16, and I just estimate the value. This comes out to be 3998. So you can see that the larger the denominator, the larger the value here, which we are using as a denominator here. If it's a very large value, it means that the total estimated population will be low. And if this value is low, it means that the total estimated population will be very high. That's it from my side. Thank you so much.